in the pre-industrial era. So let's talk about what goes on there. All right, so in terms of the process, basically you've got your source material. So this is a biological source. Now I'm just going to go through some of the common ones: corn, sugar, sugar cane, or sugar beet. And so that's a plant. Basically, these you need to process them. You need to smash them up, smash, grind, basically break them down, and filter as well. Filter out all the solids until you've just got a liquid, which is just a mix of water and sugar. Then what we do is we take that water and sugar and we ferment it. Fermentation. That produces alcohol, and then if we're going to use the alcohol as a fuel, we then need to distill it. So distillation, which means basically concentrating the amount of ethanol in the water ethanol mixture. So this will give us a water ethanol mixture. All right, so in the fermentation process, there's a quasi-chemical equation. There's something that's like a chemical equation that we need to know. Now, we don't actually get into the exact chemistry of fermentation because it's one of those multi-step biological processes. There'd just be too many steps for people to memorize. But instead what we do is we kind of give the basic chemistry of the beginning point and the end point. So this is yeast fermentation. That's the worst Y I've ever written. Yeast fermentation. Alright. So yeast fermentation begins with sugar, which has the formula C6H12O6, and that ends up forming, let's see, so we get fuzzy here because we don't actually say what happens. So we just say, oh, fermentation goes on. But eventually, that just goes through the process of fermentation, to two ethanol molecules. So two C5, C2H5OH molecules plus two carbon dioxide molecules. So that's fermentation. What are the key points? Key points are that needs to go, the optimum temperature for yeast fermentation is 37 degrees. It should be done anaerobically. So anaerobic fermentation, that means no oxygen. So no oxygen. Those are the conditions that we want to carry it out at. Yeah, and other important points are that it produces carbon dioxide as a product, and that we get 2 of them for every sugar that we burn. So there's different sugars that have this chemical formula that can be fermented, like glucose, maltose, sucrose. Yeah, all of those can be fermented down into ethanol. All right. Right. Now, the other thing is that so this process is going to go on for a bit, and we're going to get more and more of this in so we start with a water-sugar mixture. and we end up getting more and more of a water ethanol mixture. Now the thing about ethanol, one of its properties is that it's antiseptic, which means that it's quite toxic to microbes and yeast as well. So after it gets to a certain percentage, and that percentage is around about 14%, it starts to kill the yeast that's producing it. So we can't actually produce more than 14% in a mixture. So we've got this 14% water ethanol mix, and we need to distill that, which means that we need to drive some of this water out. In reality, what we actually do is because ethanol has a lower boiling point, let's get some new space. Alright, so ethanol's boiling point is 78 degrees. And of course water's is 100. So what we can do is heat it up to around about 78 degrees and then capture the ethanol that comes off and distill it out. So that would be very similar to other distillation processes where you're heating it to a very precise temperature and then cooling down the gas that comes out in order to capture that part of the mixture. Now that process itself requires heating the product, so that takes energy, and we're going to get to why that's a problem. It's part of the wider problem of using ethanol as a biofuel. Alright, so the idea is that because we started with a biological source, that biological source so that biological source has taken carbon dioxide out of the air and put it into the plant, like the sugar cane or whatever, to begin with. So it's removed carbon dioxide when it's created the sugars. And then we've created ethanol to simplify the process, and then we've burnt it in a car or whatever, in a mixture with, something else, or even purely. Now the thing is that we've consumed carbon dioxide out here. We do emit carbon dioxide at the end. The idea is, well, it's carbon neutral. And, if that's a policy objective for the government, then, the argument is, well, if you want to be carbon neutral, if you want to reduce the amount of carbon dioxide that's being released in total into the atmosphere, obviously at the end of it, it's going to release carbon dioxide, but it's consumed at the beginning. So, this is a carbon neutral kind of system. So that's the main reason being advanced for its use. Another thing about it is that it does make fuel burn a little bit cleaner in the sense that there's less soot and carbon monoxide. But there are some really serious downsides to it, and we'll discuss those now. Very important. So just do a quick pros and cons. Pros are carbon neutral, or less carbon intensive at least than fossil fuels, and cleaner burning. Okay, but the cons are really serious. The cons, first of all, more expensive. So it's just less abundant, it's less available to the human race. One of the reasons it's, I know we'll get to that in a second, but the next thing is it actually releases less energy per gram than petrol. So what that means is that if you fill your tank up, it's also got less energy per liter. But if you fill your tank up, you're going to get less distance because it's more oxidized because it's got that hydroxyl group at the end. That's more oxidized than just having a hydrogen in the end. So it's got less energy available. So as a fuel, that's a bad feature. Now, the next thing is when we grow whatever it is we grow to create the sugars, to create the ethanol, we have to use land use. So uses lots of land. That's not cheap, so it contributes to that price factor, but also it means that other things that use land are more expensive. It's competing for the use of land. So that's going to make food is going to be more expensive. So if we ever have a famine because we're using all our land for biofuels, that would be a pretty serious drawback. Its mere presence will make food more expensive, which is a problem for the world's poor. And there's a fourth problem as well. Right. So it's carbon neutral in the sense that all the sugar that's produced takes carbon dioxide, and then when you burn it at the end in your car, it uses the same amount of carbon dioxide as, so it's just reversing that reaction. That's carbon neutral. But it uses energy when you've got to harvest the sugar cane, say, transporting it to wherever it gets turned into ethanol, and then transporting the ethanol to wherever it gets used. It uses energy when we're fermenting it and when we're distilling it. So if we're using fossil fuels for that, then it's not carbon neutral, and we've actually used a whole lot of carbon dioxide just getting the biofuel to people to use. So it's not fully carbon neutral. Alright, so we've done all the equations we need to do and talked about ethanol as a fuel